Folks, welcome back. We've got a card on the bench today that's both my not favorite kind of card and absolutely my favorite kind of card. So, what we're looking at here is a GeForce 980 Ti EVGA brand that I believe to be the reference design. Now, this is my favorite kind of card in the sense that it was sent to me by a viewer and I didn't have to buy this. So I'm going to do my very best to fix this. And if I can fix it, I'm going to send it back to him. And I don't get a trophy, but I get to know that I put a card in working condition back out into the world. On the other hand, it's a 980 Ti, which we have not had good luck with. Still, this one I think might be a pretty good candidate for one we can save in the sense that I have a pretty good idea for what's wrong. So, the owner complained that when you have this card plugged in, the system won't power up. And if you've watched the channel with any regularity in the past, you know that that is a classic symptom of a short to ground on one of our 12-volt power connectors, either these two or our PCIe power down here. So we can confirm that suspicion if we get this here. We grab our multimeter. We've got our multimeter in ohms mode, and we'll put our negative probe in our I/O connector. And the pins we want to look at are the rows of pins here. We've got our latch on this side. We've got our ground pins close to the latch. And then farther away from the latch, we've got our actual 12-volt supply pins. So the one I like to use is this guy right here. Row far from the latch, second from the right with the latch on the bottom. It's one of the ones with the funky shape, not square. So we'll stick our, here, let me do it so you can see the multimeter. Stick our probe in there. Look at that. So we've got 2.3 ohms. Now, remember that number, because I'm going to show you something here in a minute that you're totally going to get why that says 2.3 ohms. If we flip the card face down here, and we look at this handy-dandy hole that EVGA has provided us in their beautiful backplate, we've got this capacitor right in here. And if one side of it should be ground, right? 0. So that's ground. Now if we measure the other side, what do we get? 2 ohms. So when we see this, we know pretty close to right away that a very likely scenario is that a MOSFET between between the 12-volt rail and the output from the VRM to the core failed. And it's become basically a wire between our 12-volt input and the GPU die. Now, oddly enough, I've actually seen several of these cards that survived many times having the core get blasted with 12 volts. So it's not necessarily a death sentence for the card that this has happened. But we do need to figure out, one, why it failed, and two, which one of the MOSFETs failed. So in order to do that, we need to get a look at the card without the heatsink on it. So we're going to go ahead and remove the heatsink now. Don't go anywhere. With our card disassembled, we can take a look and see if there's not just some obvious thing that's wrong that might provide us with a hint as to which one of these components is the short. Unfortunately, I do not see anything that is obviously the problem. Sometimes they fail pretty spectacularly, as you may have remembered from the MSI Golden Edition. But in this case, there's nothing obvious that's wrong just from looking. So we're going to have to take some more measurements, and then we're going to do a test that I'm pretty confident will tell us which one of those it is that's failed. So one of the first things we want to figure out is, how is this wired up? Because chances are not all of these are wired up directly to both of these power connectors. So you can imagine if there's a wire that went from here to here to here to here, all of those things would be connected. But chances are that's not how this is actually designed. And so one of the first things we need to know is which side of each of these pads is ground. That's probably this side. Yeah, that's ground. That's ground. Okay. So that's 2 ohms. That looks like it's connected to our core. Let's see here. That's 15 million. Okay. 15 million. Ground. Okay. So what all that probing has told us is that these power stages are wired up to our suspect power connector. So if we just go in here, careful not to touch ground pins. Okay. Touch there. See that? We've got 0. There's a wire between all of those. So what that tells us right away is chances are our problem is one of these 4 components right here. Because the only thing that connects the 12 volts to the core is these guys right here. Basically, there's nothing else unless there's damage to the PCB that somehow wired those together. And it's not impossible. I've seen it before, but it's less likely. So something else to check is, do we have continuity to our V-core output side, which is probably this. And we do. And see there, we've got basically 0 ohms. Like, our current is passing straight from there to over here, even though this, the V-core, should be in the way. Alright, so we can set the meter aside for a minute. We've done all of the probing we really need to do. Our next step is to figure out which one of these power stages is our suspect. If I had to guess, I'd guess it's probably one of these 2 right here, based on experience. But what we're going to do is we're going to flip the card over, and we're actually going to solder some wires onto the power supply input. So we're going to attach a positive wire to that guy right there, and we're going to attach a negative wire to this one. We've got our 2 power supply wires on there, and we can use that to pass current through the board and see which components get hot. So we're going to flip it over face up now, and we'll turn off the soldering iron for the time being. Okay, I've got my wires hooked up, and I've got my power supply set to 1.2 volts. That may not be enough, but we're going to try it first, and we'll ramp the voltage up a little bit as we go until we can get some results from these, up to 12 volts if we really have to. So what we're going to do is we're going to grab a little bit of isopropanol, put it in a little cap here. There we go. Doesn't take a whole lot. So we get our eyedropper and we put a drop on each one of our suspect components. There, here, and here. And if it escapes, that's okay. It means we get to test some other components. This one's got some... Notice how it pools up on this one. This one's got oil from the thermal pad on it. Okay. So, we've got that on there. And now we're ready to turn on our power supply and watch the alcohol. Let me zoom you in so you can see the alcohol better. Okay. So I've got you zoomed in there so you can see the alcohol. Now I'm going to turn the power supply on, and what we're looking for is boiling or faster evaporation of the alcohol on one versus any of the other MOSFETs there. Fire in the hole. All right, so 1.2 amps wasn't quite enough. All right, I think we're going to change tack here. There is another way we can try to figure out which one of these power stages is the faulty one. And the way we do that is just remove them from the board. And we're going to remove those guys one at a time until... Oh, you know what? We need to remove our leads. We're going to remove our power supply wires before we do that. Okay, there's one. There's two. Okay. We're going to remove our power stages from the board one at a time until we clear the short. And we'll just keep track of which one it was that cleared the short. And this is sort of not really any other way to describe this than a pain in the neck. So I'm going to start with that one there. Okay, so let's grab our meter here. All right, so we got our first power stage off the board, and we need to check our resistance here. Wait. Yeah, that's the pin. All right. Wild. That is wild. Okay. So, what this is telling us is we were able to clear our short by removing just that one power stage. We're going to do one more test. Okay, as a sanity check for the idea that removing just this one power stage cleared our short, what we're going to do is first we're going to figure out which one of these terminals here is our 12-volt supply, which one goes to the core, and which one is ground. And if I had to guess, I would say that's our 12-volt supply. So we're going to put one probe on that and go after our 12-volt input pin, and what we should see is 0 ohms. Yeah, so those two are connected. Then we'll go grab a ground pin over here. Check there. Okay, yeah, so that one is ground. And then if we measure this remaining big pad to ground, that one should go to the core. All right, and so we're going to see 1.5 something ohms. So there we go. That's looking okay. That's a little low. Card's still warm though. So what we need to do is the pad that goes here, which is actually this one because it's flipped over, and this one here, if this is the cause of our short, are going to be shorted unless, we damaged it further removing it. So let's check there. Yes. Okay. So obviously, when the card is running, we don't want that to just short 12 volts into the core. So you wouldn't want 0.2 ohms here. But what we've got is 0.2 ohms there, statically. We've got no continuity here. And we've got no continuity there. So our high side transistor in this MOSFET burned out for some reason, but none of the others did. So that means that we've cleared our short, and we could conceivably put the heatsink back on the card now and test it to see if it works. This VRM design may be smart enough that if any of the power stages aren't running, it shuts off, but it's worth a shot. All right, well, I went and had a look at the data sheet for this power stage, which is an FDMF 6823A by On Semiconductor. And what I was able to determine is there's nothing in the data sheet to suggest that any of the pins on that, and it has 40 pins, but none of them are used in order to tell the controller that there's a problem other than there's a thermal warning. But it's just a warning that it doesn't necessarily shut the phase down. So as far as I can tell, there's nothing that would prevent the card from working if we plugged it back in, as long as there's no further damage to the card. And as we showed before, we've cleared our short. So most graphics cards can run on less than all of their phases. So this card has 8 phases. It should be able to run on 7 of them. So what we're going to do now is put the heatsink back on, and I think we may connect the fan up as well, and just test the card and see if we can boot into Windows and install a driver. And if we can, then we can go about looking for a replacement for our power stage. put our little foam blocks down so the fans can breathe. Just here like that. Okay. So we got fans spinning. Yes! All right. So we've got a hard drive plugged in here. Let's just see if it boots into Windows. Where's the mouse? All right, well that's not a good sign. Let's just give it one more boot to see what it does here. Aha! Look at that. Alright, so let's let it sit for just a minute and work out whether or not it's gonna install a driver. There we go. Okay. So let's go see what we got in the device manager. There we go. 980 Ti. Alright. So our card's looking pretty good now. So I'm going to go ahead and shut this down. Alright folks, so there we go. We've got the card working now. Frankly, this is the most common failure I've seen on these cards, where you just have one of the power transistors burn out and cause a short, and somehow that doesn't seem to damage these 980 Ti dies. They seem to be pretty tough, and if you can get the VRM fixed again, they work just fine. So we're going to take a shot at actually replacing this in our next episode, but it could be weeks before I can get my hands on one of those, because they don't just sell those at Walmart. You got to get them from eBay, and in reality you're ordering it from somewhere in China. So it's going to be a little while before I can get my hands on that, and for now we're going to call this a victory. Tune in next time and we'll get the new one on the board, and we'll see if we can't get the VRM working 100% so that this card can go back to its owner in 100% condition. Until then, I hope you found this entertaining, if not terribly helpful, and as always, I'll see you in the next one.